Okay, good morning. Take two on this. We're going to start off just a little bit late because technology has been fighting with me. Hopefully this comes out as a great recording. So today we are talking about section 4.1. We are going into rates and ratios. And ratios are a fun thing that a lot of people struggle with. It's one of those things that when you understand ratios, they are very powerful. When you don't understand them, you always feel lost, especially when you're dealing with fractions, decimals, percents, or odds, things like that. They're why casinos exist. If people knew the ratios and expected values, no one would ever gamble. But I digress. Let's get to our point. So on this, it describes a relationship between two quantities. I like to think of it as a this to that. Now, with this, we have out of 300 students in the class, 175 are female. Express this as a ratio. We would say this is 175 to 300, or we could write it as a fraction. These are the same thing. So 175 over 300. Now, if I want to, I can use the fundamental theorem of arithmetic. I can break that 175 down. So 175, there's definitely a 5 in there. That would be what? 4 plus 3, 7 times 5, 35. Yeah. Pull out a 5. That would be 7, 7, and 1. So we have 25 times 7. If I had 7 quarters, I would have $1.75. That makes sense. So we have that address as 5 times 5 times 7. And we're going to put that over 300, which is the same as 3 times 100. So times 2 times 5 times 2 times 5. And all I did there was think to myself, well, self, 10 times 10 is 100. 2 times 5 is 10. So 2 times 5 times 2 times 5 would get me to the same place. Thank you to my ability to organize and break down numbers thanks to the fundamental theorem of arithmetic. And of course, the commutative property of multiplication. Multiplication can switch places. So 2 times 5 is the same as 5 times 2. Now I'm going to look at that and say if it's the same top and bottom, it's going to reduce. So 5 divided by 5 is 1. 5 divided by 5 is 1. 1 times 1 is 1 times 7 is 7. So I get 7 over 3 times 2 is 6 times 2 is going to be 12. So we can say the ratio is 7 to 12. That's 7 females for every 12 students. So there are 7 females to 12 students, or this to that. For every of this many, there are that many. For every 7 females, there are 12 total students. All right. A rectangle is 14 inches long and 8 inches wide. What is the ratio of length to width? Well, on that, I'm just going to put the length is 14 inches. The width is going to be 8 inches. Now I can call that 2 times 7 over 2 times 2 times 2. Thank you to the fundamental theorem of arithmetic, which states I can represent any composite number as its own unique set of prime numbers. Now I just reduce. 2 divided by 2 is 1. 1 times 7 is 7. 2 times 2 is 4. So this is 7 to 4. Now, some people's brains will scream this is an improper fraction. Don't worry about that. When we're talking about it in terms of ratio, we don't bother making it a proper fraction. We don't bother turning it to a mixed number. All right, so on this we have for field trip, we have 6 teachers with 63 students. So what's our student to teacher ratio? Well, we can say that's the same as 2 times 3 over 3 times 3 times 7. 7 times 9 is 63. Look at that. I think we found an error. So now we're going to say, okay, 3 divided by 3 is 1. 2 times 1 is 2. And 3 times 7 is 21. So we have 21 students per teacher. Does that seem right? No, we have 21 students per 2 teachers. So about 10 and a half students per teacher. There we go. That's my brain was itchy. There we go. Because it's itchy because you can't cut kids in half. Don't do that. That's not right. Don't even think about it. One teacher got 11, the other got 10. Okay. Seriously, people. Who would cut someone in half? You're right. You're our favorite student. We cut you in half so you can be in 2 classes. The whole class was traumatized. Yeah, let's not cut anyone in half, please. Okay. So we can always write them as simplified fractions because it's a this many to that. So 5 gallons of gas, you drive 150 miles. For every 1 gallon, you got 30 miles. We're not changing the values because a ratio is the same thing as a rate. It's a this many to that. One of the more common rates you drive in is miles per hour. That's a rate of travel. I know that makes me crazy too. But using that, you can figure out things by finding equivalent fractions. And for anyone who feels lost, don't worry about it. Unit rates are where we can have for every one of these a certain amount. So a good example would be for 3 feet is equal to 1 yard. This is a unit rate because this is single, so it's a unit. And that's a relationship related to a unit. And so on this, we have here a cost to ounces rate. So a bottle of shampoo sells for $3.60. Wow, that's cheap shampoo. Must not be for women. I'm telling you, I have a daughter and a wife, although my daughter has moved out. But anyhow, the shampoo they buy, you would think it had gold flakes in it. Back to what we're talking about though. We have here 360 to 24. Well, we can simplify that down. 360, we're going to pull out the primes. Divide that by 2 is 180. Divide that by 2 is 90. Divide that by 2 is 45. Divide that by 5 is 9. Divide that by 3, you've got 3, 3, 1. So the address would be 2 times 2 times 2 times 3 times 3 times 5. All that over 24. And we can break that bad boy down. Divided by 2 is 12. Divided by 2 is 6. Divided by 2 is 3. 3 is 1. So its address is 2 times 2 times 2 times 3. And so when we do that, we go, okay, 2's reduce out. And we get here 3 times 5, so 15 to 1. Notice I took away this decimal. I have to put it back. So 15.15 to 1, or we could just call it 15 cents per ounce. With that, we will do these ratios in this terms. I'm just going to show you something a little bit different, and that is sometimes you'll have to do a conversion with multiples. So you may end up converting, say we have a projectile that starts at an initial velocity. So velocity at the initial is, let's say it's traveling at I don't know. We'll go super slow. 500, well, let's do paintball. 300 feet per 1 second. Now, I don't know about anyone else, but I don't know anything relative traveling in feet per second. Like, I do move in feet per second, but I don't remember the last time I looked at my watch and it's like, hey, guess what? You're jogging, you're moving so many feet per second. But I do know miles per hour because I'm used to driving a car. And that gives me something, a frame of reference. And so I know in miles per hour, and I have a frame of reference. I wonder how fast the paintball is traveling when it leaves the muzzle of a paintball gun. So we'll say 300 feet to 1 second. I'm going to remember good fences make good neighbors. So next I need to know there are 5,280 feet in 1 mile. Here, I'm going to move this real quick. Out of the way. And then I'm going to say to myself, okay, there are 60 seconds in 1 minute, and there are 60 minutes in 1 hour. Now, before I ever do math, when I'm doing these conversions, I'm going to check myself by seeing what crosses out. So we have feet divided by feet. We have seconds divided by seconds, minutes divided by minutes. When it's all said and done, I'm looking at mile and hour as my units. I wanted to go from feet per second to miles per hour. That looks good. So now I just do the multiplication, 300 times 60 times 60. And this is why I'm thankful that God gave us calculators. So we say, okay, 300 times 60 times 60. And that's going to give me 1080000. That looks like a pretty large number. Over 1 times 5280 times 1 times 1, that'll be 5,280. So divide by 5280. And we get that that is traveling at a rate of about 205 miles per hour. No wonder those suckers hurt when they first hit you. At point blank range, my older brother's a jerk. What can I say? Okay, so that's why you want some distance. It slows significantly because they're on shape. But with this, when you're doing conversions, this is an example here of unit rate conversion, where we're going from 1 unit to a completely different unit. So feet per second to miles per hour. Don't worry, your homework won't get into that. It'll stay a lot simpler. It just wants you to remember that it's a this to that, and that you can reduce it. So it's easier if you write it as a fraction. If you write, A is to some B. Just remember there is no 0 in the denominator because that's crazy people world. Are there any questions? All right, well, thank you so much for coming. I hope that you've had a good lesson and enjoyed this. I am available for tutoring and additional support. Thanks again for coming.